Okay, someone can mute their computer? Alright.
Derived from is a word that means to index. It's not that exactly, but it's used as Z-N-A-K-Y.
I think I can find out whose computer. Opula William, your computer?
Very easy again. What's that?
Alright. Alright, so now what we are now going to do is apply the summation formula to analyzing iterative algorithms. Again, iteration and summation go together. So we can apply these formulas to analyze the time complexity of iteration based algorithms. So we are going to start from a very simple case and then we slowly increase the complexity. So let us do what we already saw in this course or in 228. Let us say, or even this should have seen in 119, finding the maximum element in an array. And we know the logic, right? So we start with a of 0 as our temporary maximum and go through a for loop for I equals 1 to n minus 1. If you come across something that is at index a of I greater than the temporary maximum we know, we set that maximum value to be a of I and keep going to the rest of the array in that loop. And when you come out of the loop, we have found the global maximum. That's the logic, right? So now what we want to analyze is the time complexity. Now we did that also earlier. The first step is to identify the basic operation, which is the comparison inside the if statement of the for loop, and we need to decide, is there a best case different from worst case or is always the same. This is a maximum integer problem or a minimum integer problem. Either way, we have to go through the entire array using the for loop starting from index 1 to n minus 1. So that means we will always do the same number of comparisons, which is going to be what? For every index we are going to do one comparison. So we are going to do one comparison I equals 1, another comparison I equals 2, and another comparison I equals 3 up to n minus 1. And that's what is the summation here. So sigma I equals 1 to n minus 1, that's our loop index, and for each iteration, what is the number of times we do the basic operation? We do one comparison for each iteration, and that's why we write a 1 inside. So this is a summation we want to solve now for the number of times we do the comparisons. So that's why I wrote C of n, the number of comparisons we do for a given n is sigma I equals 1 to n minus 1. 1 is the number of times, always I said earlier, what goes inside the summation when you analyze an algorithm is the number of times we do that basic operation for a particular iteration or for any index I. So in this case it is one comparison. So this fits within that upper limit minus lower limit formula. So n minus 1 minus 1 plus 1. So n minus 1 minus 1 plus 1 is n minus 1, which is state of n. Okay. The sequential search problem also can be analyzed with this approach. So a given array and search key k. So what logic is here, go from index 0 to n minus 1 and at any index, if a of I equals k, we stop and say we found the index where the k is. Otherwise we keep going through the entire array and then say the index is not found if you just no matching key. Now in this case, the algorithm, the basic operation is this comparison, and there's a best case different from worst case. The best case is just one comparison if the search key is at index 0, whereas the worst case is to go through the entire loop. Now, so we know best case is one comparison, there's nothing for us to find out. For the worst case, we can use this summation approach to find out. So I did not show up here, but I'll type it out after the class, but let me do it here so we still have time. Yes. So the for sequential search, the summation is going from sigma I equals 0 to n minus 1 So I equals 0 to n minus 1, and then again for each iteration we do one comparison, whether a of I equals k. That's one comparison per iteration. So what goes inside summation is 1. So this again fits within the formula upper limit minus lower limit plus 1. So upper limit is n minus 1 minus 0 plus 1, that's going to be n. So that n is the number of comparisons we do at the worst case, and that's what we got earlier also, but where we just looked at as an array as an example and counted it. But we could do this as a more general. We don't really need to go through an example now to say what's the number of times we do the basic operation at the worst case. So the worst case, we run the for loop from index 0 to n minus 1, and for each iteration we do one comparison, and this is the answer. So the number of comparisons we do at the worst case is n. So here we have best case different from worst case. So we have to use a big O notation and say the time complexity is big O of the worst case, which is n. As in the previous problem, which I did not complete it, but since here the best case is same as worst case, and how many times we do the comparison? N minus 1 times, and we know that is the rate of n. This is a tight bound because best case is same as worst case. As here best case is different from worst case, so we can only use a big O notation, and big O of worst case is big O of n. So we'll stop with this. We'll come back and look at the other algorithms next class. Let me just quickly take your attendance and then you can log out. Let me stop the video for a second.